So now we're going to do question 6, where we are given this equation of our graph, which is f of x equals to log of base a x, right? And we are given a point which is 4 and minus 2. So there is the point there in the graph, and we also know the x-intercept, which is 1, and the y being equals to 0, right? So that is the information from the graph, and we are asked in 6.1 to identify or show that a is equals to 1 over 2, right? So remember that we have our f of x there, our f of x being equals to log of base a x, and we're asked to prove that a is equals to 1 over 2, right? So this is the requirement to show that. So how do we show that? We're going to use this point here, right? The point of 4 and minus 2, right? So you can substitute it in this equation here. So where there's x, you're going to put 4, where there's y, you're going to put minus 2. So it's going to be minus 2 is equals to log of base a, and then where there's x, you put 4 there, and then this base here will be equals to, it's going to be a to the power of this minus 2, so it's going to be minus 2 equals to this 4 here, which is equals to 4. And we can either multiply by 1 over minus 2, or we can just say 1 over a to the power of 2 is equals to 4, and then we cross multiply. We're going to have 1 is equals to 4a to the power of 2, and then you divide by 4 both sides, and we'll have a squared is equals to 1 over 4. So this is a squared is equals to 1 over 4, and then we'll put the square roots both sides, and then we'll have a is equals to plus or minus 1 over 2, right? But we know that our base is going to be positive, so it's going to be a is equals to 1 over 2. So we've proven that a is indeed 1 over 2. So now 6.2, we are asked to determine the equation of the inverse, right? So remember that we just proven in the previous question that a is equals to 1 over 2. So our f of x is equals to log of base 1 over 2x, right? So to find the inverse of this, we know that f of x is equals to y. So you can simply write y is equals to log of base 1 over 2x, and then we can swap our x and y. Where there's x, we're going to put y. Where there's y, we're going to put x, right? So here we're just going to write x, and here we're just going to write y, right? So it's going to be x is equals to log of base 1 over 2y, and then we write our equation properly. So this 1 over 2 will be to the power of x, right? It's going to be 1 over 2 to the power of x is equals to this y here, which is equals to y. So our y is equals to 1 over 2 to the power of x. So this would be our inverse. So this is 2 here. So it's y is equals to open bracket 1 over 2 close bracket to the power of x. So that is our inverse of the function of f. So now 6.3, we are asked to write down the equation of h if h is the reflection of f in the x-axis, right? So we want to find the equation of h if h is the reflection of f in the x-axis. So h is the reflection of f in the x-axis. So this is really important. Where is the reflection happening? In the x-axis. So this is our x-axis, x-axis, right? So the graph reflects about the x-axis. So for us to find it, we know very well that if it reflects about the x-axis, it means now where here it's the coordinate is 4 and minus 2, right? So if it reflects about this x-axis here, if you wanted the same point here, but here you will find that the coordinates, the 4 remains the same, but the y changes. So the y was negative 2 here, but now it's positive 2, right? So you're going to use these these coordinates now, because they are a reflection about the x-axis. They are a reflection about the x-axis, so you're going to use them to find the equation of h of x, right? So remember that our f of x was equals to log of base 1 over 2x, right? But now, since we're having this reflection, we can simply say our h of x is equals to log of base. We can still maintain our base, or we can just write a and x like this, right? And then substitute these coordinates. So where there's x, you're going to put 4. Where there's y, you're going to put 2, right? So it's going to be 2 here equals to log of base a and 4 there to find the value of a, right? So it's going to be this a here to the power of 2 is equals to this 4 here. It's going to be a to the power of 2 is equals to 4, and then you put the square root both sides, so our a value is equals to plus or minus 2. We're going to take the positive 2, so a is equals to 2. So now we found the equation of h of x. So h of x is equals to log of base 2x. So this is the equation of h of x. So 6.4, we are asked to determine the values of x for which log of base a x plus 4 is greater or equals to 0. So how we find the values of x for this, for this expression here? We know very well that x plus 4 must be greater or equals to 0. Or let me just say that we transpose the 4 to the other side, we will have x being greater or equals to minus 4. So this is the first solution of x that we should expect in our solutions. And the second solution can be, we have log of base a into x plus 4, right? Greater or equals to 0. So this a here will be to the power of 0, remaining x plus 4. So it's going to be x plus 4 is greater or equals to a to the power of 0. Anything to the power of 0 is 1, so it's going to be x plus 4 greater or equals to 1. So this x plus 4 greater or equals to 1, and then you transpose the 4 to the other side, we have x being greater or equals to 1 minus 4, right? So it's going to be x greater or equals to minus 3. So this would be the second solution of x. So remember, this is the first solution of x, the second solution of x. So now you need to analyze your solutions now. So we have x being greater or equals to minus 4. We have x being greater or equals to minus 3. So you're going to go back to your equation, this equation here, right? So you have log of base a x plus 4, right? So we want a solution of x that when we substitute it here, it's going to give us a solution that is greater or equals to 0, right? So a solution that is positive or equals to 0, right? So if we substitute x being equal, if we look at this minus 3 here, if we substitute x being equals to minus 3, it's going to be log of base a minus 3 plus 4. So when you add minus 3 plus 4, it gives you a positive value, right? It gives you a positive 1. Right, minus 3 plus 4 it's 1, so it's going to be log of base a 1, right? So this can definitely give us a solution that is either greater or equals to 0, right? So that tells us that x greater or equals to minus 3 is our solution. But now let's test for, because it says greater or equals to minus 3, right? Let's test x being equals to minus 4. So we have log of base a minus 4 plus 4. So minus 4 plus 4 gives us log of base a 0, right? Which you can still consider it, considering the fact that minus 4 is also one of our solutions here. So you can still consider this one here. But now let's test another value that is greater, because this says greater or equals to minus 3. So let's test a greater value also. We're going to test x being equals to -5. So if we were to say log of base a, -5 plus 4. So -5 plus 4 gives you a log of base a -1. So this doesn't give you a solution, right? It doesn't give you a solution. So it tells you now that this solution of x here that we found being greater or equals to -3 should not exceed -4. So x being greater or equals to -3, right? But x must not be, let me write it properly, x must not be greater or equals to -5. So it must either remain, it must be less than or equals to -4, but it must also be greater or equals to -3, right? So let me properly write that, but at least I showed you the situations on what happens. But as long as now we know the final step of this problem here, since we tested. But if you didn't understand what I was doing, please write your questions or just comment in the comment section below. But as we concluded, or as we tested, we know that x must be greater or equals to -3, but x must also be less than or equals to -4, because if x is equals to -5, it gives you a negative log because it's x plus 4, where if you substitute log, so this is a, base a -5 plus 4, so it gives you a negative log. It's log of negative, it's -1 base a, so which won't give you a solution. Hence I say x must be greater or equals to -3, or x must be less than or equals to -4. So someone can simply write it as x must lie between -3 and -4. So both these are correct. So that is the solution of your values of x.